have an increase of 4 times the outside electric field strength. This is why the electric field and the enhancement of the electric field because of cavities can be so dangerous carrying the energy. But falls can happen anywhere. For example, birds are one of the primary causes of falls in transmission lines, but these are visible external failures. There's another kind of failure, the one that you don't see from the outside. That's inside the cable itself. For example, the insulation can have hiding defects, such as a crack. But what happens when we introduce a cavity in the cable? Permittivity of cavity, let's assume that it's air, then it's 1, and A for air. And let's write it with green for the insulation. So permittivity of the insulation, and assuming that it's a XLPE cable, then that would be 4. Inside of the air gap, the permittivity is 1. So what happened to the electric field inside of the air gap? Well, we can rearrange this equation, and by knowing the actual electric field and relating it to this equation here, then we get this equation, meaning that inside of the air gap, we would actually have an increase of 4 times the outside electric field strength. This is why the electric field and the enhancement of the electric field because of cavities can be so dangerous in coaxial cables and high voltage cables, because it causes stress in the material